Okay, this is the third and final video for Unit 1. So we are on the back of your guided notes here. All right, we're going to work on radicals. All right, so radicals are basically just square roots. There's nothing different. The name is different, but that's about it. So when we talk about radicals, we're referring to square roots. So simplifying radicals. So in Math 8, you guys would estimate to the nearest tenth, but in algebra, we simplify square roots. So what we're going to do is separate the square root into a perfect and a non-perfect square root. Take variables out in pairs, and then simplify what you can. So on this first example, what we want to do is the 4 is going to stay as a 4, but we want to break the square root of 18 into two numbers that when multiplied together would equal 18, but we want one of them to be a perfect square. So 3 and 6 come to mind as equaling 18. The problem is that 3 nor 6, neither one are perfect squares. So if you think a little bit deeper, you should come up with 9 times 2. So right here, 9 times 2 is the same as 18. So all I've done is rewritten this. All right, now I'm going to go through and simplify. The 4 remains a 4. The square root of 9, I'm going to rewrite as a 3. The square root of 2 stays as a square root of 2. So this just dropped down, this just dropped down, this I simplified. And then I'm going to make this look a little bit better. We can multiply out here to get 12 times the square root of 2. So that is your simplified answer for 4 square root of 18. All right, next one. Square root of 75, m to the third n squared. So this is where I mentioned that you're going to take variables out in pairs. So the first thing we're going to do is rewrite 75 as two square roots that will equal 75 when we multiply, and then I'm going to go ahead and leave the variables inside. All right, so thinking of 75, I know I can divide it by 5, but that doesn't help me out. But 25 times 3 is 75. So now I'm going to go through and simplify. Square root of 25 becomes a 5. So I'm replacing that with that. This is square root of 3, excuse me, stays the same. All right, since I'm taking a square root, that means that I have to take it in a group of 2. All right, if I was doing a cube root, I would take the variables out in groups of 3. If it was a fifth root, I would take them out in groups of 5. So since it's a square root, I'm going to take it out of a group of 2. So if I have 3 m's, that tells me that I have one m, one group of m's that can come out, but that's going to leave 1 m inside. And then for n squared, since I have 2 n's, I know that that's a group of 2, so I can take that out, and that would leave no n's left inside. So just to rearrange this so it looks better, 5mn, and then in the square root is still 3m. So that's just one way to talk through how to get that done. But when you're working with the variables, if it's a square root, you take them out in groups of 2. All right, next up, we are going to work with adding and subtracting radicals. And the deal here is it's going to work just like variables. We have to have like terms. And what makes radicals like terms is if they are the square root of the same number. So first thing I'm going to look at is I'm ready to give up because these two are not like square roots. However, I might be able to simplify. So let's think about, we could break this into square root of 3 and square root of 2, but that doesn't help us. So this one is already simplified. All right, over here, we could break this into the square root of 4 and 6. Then we know the square root of 4 is 2. So now we have 2 times 2, square root of 6. So now if we work this, finish this up a little bit, that's going to be 2 square root of 6 minus 4 square root of 6. And now they're like square roots. So we will get negative 2 square root of 6. All right, over here, same thing. We're going to go through and simplify first, and then we can see if we have any like square roots. All right, so first thing, I'm thinking 9 times 5. So the square root of 9 would be 3, and the square root of 5 stays inside. So I'm going to do some more mental work here. Square root of 5 can't be simplified anymore, so that one's fine. Square root of 20 would be 4 times 5, but the square root of 4 is 2. And then square root of 6 cannot be simplified anymore, so that's going to stay the same. So now I'm going to go through and look for like terms, and those three are like terms, so I can go ahead and combine these together. Looking right here, those would completely just cancel each other out. So negative 3 square root of 5 minus 2 square root of 6. All right, moving on to multiplying. So basically we're going to follow the rules we did with polynomials where we will FOIL. Whenever we multiply, we can multiply the outside numbers with the outside numbers and the insides with the insides, and then